If you want to change how a class is shown in the inspector, a property drawer is the way to go. It allows you to make a custom solution that perfectly fits your needs, and you can easily copy it into other projects if they use the same class. This is particularly useful for general purpose classes like the one we'll build in this video. We'll make a class that holds an array which maps to a specified enum. If you watched the last video in the editor scripting series, we're attempting to solve the same problem but in a new and better way. We're still making property drawers, but in the previous videos we made property attributes that we then made property drawers for. Now we're making a regular serializable class which we then make a property drawer for. You'll see that this process is very similar, and one could even argue that it's simpler and more direct. So while this video exists in the context of the larger editor scripting series, it can be watched on its own without any problems. And you don't necessarily need to know anything about it beforehand. I will, however, not go as far in depth when explaining things that already were explored in the 3 videos about property attributes. Additionally, the example itself in this video is significantly more advanced than what we did in the first of those 3 videos. So if you're completely new to all of this, that video might prove an easier entry point, and it's probably also a better thing to learn about first. If you're not completely new, or just enjoy a good challenge and don't have all day to watch other videos, let's jump straight in. As mentioned, today's problem and the motivation for it was explained in detail in the beginning of the previous video. Let's recap the essence of it now though. I have a fresh Unity project here, and I'll begin by making an example script and opening it to demonstrate. We'll make an enum, and for the sake of continuity, let's say that it represents various text styles. We'll call them normal, heading, warning, and error. Now we want each style to have some data tied to it. For this example, let's say we want to have a font size and a color for each text style. So we'll make a public class text style and give it the serializable attribute so that it can be stored on the disk and drawn in the inspector. Then we'll give it a public int size and a public color. The idea is that we want an array of objects of this class where each object maps to an enum entry, which we can then easily edit in the Unity inspector. So we'll make a serialized field, private, text style, text styles. I'll go into Unity and make a new game object to put this script onto so we can see what happens. The issue now is that when we edit this from the inspector, we won't be able to see which object belongs to which enum entry, and there's no guarantee that the array will have the correct size. In the previous video, we solved the problem by making a property attribute that we assigned to this array, which allowed us to make some limited changes to the size of the array and display the correct names by each object in the inspector. In this video, we'll solve the problem by making a new class which will act as a container for our array, giving us considerably more control. So let's get to it. We'll begin by making a script for the class, which we'll call EnumDataContainer. Then we'll make a directory called editor, in which we'll make the script for the drawer, which will be called EnumDataContainer drawer. It's important that the directory is called editor, as this tells Unity not to compile it when building the game. Let's begin by opening the class. So this is the class that we'll use in code and which will have its appearance modified by our drawer. First off, we'll just include the system namespace, as we'll need it in a moment. And let's also remove the inheritance. This class is meant to be the container of an array, so let's define one. We're actually going to make it private because we won't interact with it directly from the outside. Let's just call it content and explicitly give it a value of null to avoid the annoying warnings in Unity. Now comes the question, which type of array should this be? We want the container to work with any serializable class, but we don't want to just make it of type object. The most obvious reason being that it won't show up properly in the inspector. We also don't want to make a different version of the container class and drawer for each different class we want to use it for. This is exactly the kind of problem that generics exist to solve, so let's make use of it. There are a ton of great tutorials on YouTube about generics, and we also want to make one at some point. So if you're watching this video a bit into the future, you can check out our channel and see if we've made it yet. But for now, I'll just show how we use it here and then quickly explain what is happening. To make this class generic, we open chevrons right after the name of the class and write a name which will work as a proxy for whichever type is specified when the class is actually used. I'll just call it tValue. Now we can make the content array of type tValue, meaning the type of the array will be exactly what the user specifies when he initializes the class. So if we head into the example script, we can turn our text styles from an array into our new class EnumDataContainer. We then open chevrons and write the type of data we want to store, which in this case is text style. Now let's head back into EnumDataContainer and think about how we want to be able to interact with the content of the container. It would be really neat if when using this class in code, it could be treated as if it's an array itself. We don't want to have to write textstyles.content to access the data if we can avoid it. For that we'll use a neat little trick called an indexer. Here's how it works. We make a property which will be of type tValue, and then we name it this and open square brackets in which we write int I. Then for the body of the property we just write a getter which will return the content item at index I. I'll head into example and show you what this little piece of magic has done for us. If I just open a method, I can now write text styles and then use square brackets to directly access any item in content, exactly as if text styles itself was the array. This makes it so that it's actually no more of a bother to work with EnumDataContainer in code than it would be to work with an array. Let's get rid of this and head into EnumDataContainer again. The point of the class is that its data will be managed from the inspector and just read from code, so we won't give the property a setter. It might be the case that we want to read the length of the content array at some point, so let's just make a property for that. Public int length get return content.length. Now our class behaves even more like a regular array. Now, we of course also want some way to specify which enum the container should map to. There isn't a great way to do this. I'll just show the solution that I figured out and prefer, even though it's a little bit weird. First we'll expand the generic part of the class to include a second parameter, which I'll call tenum. The idea is that you pass in the type of enum you want here. If we leave it at this though, we face the problem that a user of this class can put in any type, including ones that aren't enums, which would result in errors in our drawer. Therefore, we want to place a constraint on the allowed types, which we do by writing where tenum : enum. Then we'll make a private variable of type tenum, which we can call enumType. The only purpose of this variable is for the drawer to find it and read its type. The value of it makes no difference. The reason that we need to make this variable is that the generic tenum won't be serialized, so otherwise there'll be no way for the drawer to know what tenum is. If anyone finds a better way to do this, feel free to tell us about it in the comments. Finally, we need to tell the compiler that it's safe to serialize this class, so we give it the serializable attribute. We also need to give our variables the serialized field attribute, so that they actually can be stored and read by our drawer. That's done for now. Let's go add tenum in example and then make a cool drawer. This is the class that will be our drawer, meaning it will define how EnumDataContainer is displayed in the inspector. Making this will be almost exactly the same as if we were making it for a property attribute. The only difference being that we of course won't have an attribute with potential information to access. First, we'll be using Unity Editor, which includes pretty much all the tools we'll be using. Next, to tell Unity which class this is a drawer for, we'll give it the attribute custom property drawer, type of EnumDataContainer. And then we just need to make it inherit from property drawer. From a drawer, you can get access to all the serialized fields in the class that you're making the drawer for. So let's think about what information we need. First, we need a reference to the variable called content, as it contains the data that we actually want to show. So we'll make a private serialized property content. A serialized property is, as the name suggests, simply an object that holds a reference to a serialized field, and it also contains some functionality to interact with it. If it helps, you can think of it as something that has access to the file where the information about the field is stored. We also want a reference to enumType, so we'll write private serialized property enumType. To make this drawer, we'll need to figure out how much space it needs in the inspector, as well as what to draw. We'll begin with the space issue. So we'll override get property height and then delete the default line. When Unity needs to draw the class in the inspector, it first calls this and clears an amount of vertical space equal to the number returned. We are passed two parameters, the first being property of type serialized property. This is a reference to the field containing the class itself. So for our particular case, it references the variable called textiles in example, which of course is of type EnumDataContainer. The second parameter is the label that it wants to give our class in the inspector. First, we want to make sure that we have our reference to content, as we don't know anything without that. So we'll check if content equals null. If it does, we'll need to search for it. To do this, we need to take our property and do a search on it for content. So we call find property relative on it, which lets us pass in the string content. If the string matches the name of a variable in the class, it'll return a serialized property pointing to it. So we can simply set content equal to this. We'll then do the exact same thing for enum type. Now we want to actually calculate the height that we need. I want to be able to collapse and expand this in the inspector, so we'll need some fold out functionality. We will implement that in onGUI, but right now we just need to know that if it's collapsed, we only need enough space to draw one line for the fold out and the name. If it's expanded, we'll need space for that line as well as everything inside. The standard line height is 16 pixels and we'll actually need this number in multiple places, so I'll just add it to my variables. Private, constant, float, fold out, height, 16. Back in get property height, let's make a temporary float height and set it equal to fold out height. Now we need to check if the fold out is expanded or collapsed, and this is actually very easy to do, as property already has an is expanded field for us to interact with. If it is expanded, we'll need to add something to the height for each item in our content array. Therefore, we first need to make sure that content actually has the right size. We access the size of content by writing content.arraySize. Then we need to set that equal to the size of the enum. Remember that we in the container class have a variable of the correct type of enum, and that we in the drawer have a reference to that called enum type. Accessing the names of this enum is as simple as writing .enumNames, and then we can just get the length of that. I'll just wrap this in a conditional statement. Finally, we have all the information we need, and we can make a for loop to go through content. In the body of this, we'll increase height by editor GUI.get property height and passing content.get array element at index I. This simply takes an element of content and asks editor GUI how much space it currently needs to draw it. Notice that this method has the same name as the method we're currently overriding. It automatically takes everything into account, including if the item itself is collapsed or expanded, or if it has any children of its own. Exactly the same functionality as we're in the process of giving to our own drawer. It is possible for us to use this because when we draw the GUI later on, we'll just use something called editorGUI.property field to draw each item. At the end, we can return height. Now, let's override on GUI. This is where we actually do the drawing. You can see that we get the same two parameters as before, but now also a rect, which simply is the area on the screen where we have space reserved to draw. First off, we write editorGUI.beginProperty and editorGUI.endProperty. These ensure that prefab overwrite functionality is handled correctly, and we must write our code for drawing in between them. We'll start by making the foldout. So first, we need a new rect for it to be in. Rect foldout rect equals new rect. This is meant to be at the very top and have the height we specified earlier. So we pass in position X, position Y, position width, and foldout height. We can draw the foldout by going into editor GUI and calling foldout, which takes three parameters. First, it needs to know where to be drawn, which of course is the foldout rect we just made. Then it needs to know if it should be expanded or collapsed, so we pass property.isExpanded. Finally, it needs a label, and that can just be the label that we're given through onGUI. Of course, the foldout is supposed to expand and collapse each time it is clicked, and that is handled by this method returning a boolean, indicating the state the foldout should be in the next time it is drawn. So we can set property.isExpanded equal to this. So property.isExpanded starts out with some value, and the foldout is drawn accordingly. Then, each time it is clicked, it returns the opposite value and is thus drawn properly next time. Let's just quickly have a look at this working in Unity. If the foldout is collapsed, we're done. But if not, we need to draw the elements. So let's check that. We'll be using a loop to draw each item in content. And it'll be necessary to have a variable to keep track of our current Y position, as that will increase for each item. It'll be a float add Y that starts at foldout height, as we want to start drawing right under it. Let's make a for loop running to content.arraySize. For each item, we first want the rect to draw in, which will be a new rect at position X, position Y, plus add Y, position width, and then we can get the height in the same way as we did before with editor GUI.getPropertyHeight of content.getArrayElement at index I. Then let's increase add Y by the rect.height to prepare for the next item. And then we simply draw the item with editor GUI.PropertyField, which itself will figure out how it wants to draw the item. We will pass in the rect and content.getArrayElement at index I. The label will be a new GUI content where the text is enumType.enumNames at position I, which of course will ensure that each item has the proper name corresponding to the enum. Finally, we pass in true to tell it to also draw any potential children of the item. It's about time we went to have a look at our work in Unity. We see our foldout as well as 4 different entries, each with its proper name and the ability to be modified like you'd expect. There's one thing that looks odd though, which is that the items aren't indented relative to the foldout, which is how things are usually displayed in the inspector. Let's hurry into the script and fix that. Editor GUI has a static variable called indentLevel, and if we want to increase the indentation of everything we draw, it's as simple as incrementing this number. If you want to, you can decrement this again after you're done drawing, although it's not strictly necessary in this case, as we won't be drawing anything more, and Unity handles resetting it between onGUI calls. But that's that. We now have a class that behaves like a read-only array when you use it in code, and when looking at it from the inspector, it automatically gives itself the correct size and names and such. There's no risk of accidentally losing data by decreasing the size of the array like there was in the property attribute solution I made in the last video, and it also just looks better. When you make use of property draws for yourself, it of course doesn't have to be as advanced as this. Most of the time, you use property draws when you already have a class that you just want to look differently. While in this video, we made a new class to make an array look and behave differently. I simply wanted to show you a deeper level of how useful property draws can be, hopefully inspiring you to get more creative with them. If you've also seen the videos on property draws for property attributes, you might now be wondering if you generally should be using that, or if it's superior to make a property draw for a class that isn't an attribute. As I just said, if you already have a class and you know that you always want it to look a certain way, there really is no reason to not just make a draw for the class itself. Similarly, if you have a class or some other data type where you only want it to be drawn a certain way sometimes, the obvious choice is to make a property attribute for it and then a drawer for that. Personally, if I have a class and I'm unsure if I'll want it to always look a certain way, I tend towards making an attribute to give myself the flexibility to make the choice for each case. But one could rightly argue that it's unnecessary clutter in the code to have attributes if you end up not really needing them. Then there are times where you face a problem like we did in this video, where the most obvious choice is to make an attribute, but you realize that there might be great potential in making a new class to solve the problem instead. This time, I think our approach in this video turned out to be superior to the one in the previous video, but there's no guarantee that it'll always be like that. My best advice is to take a moment to think through what you can do with each approach and then just give it a shot. If you want to practice, you could try going both paths as I've done and see which one turns out the best. This will help you get a good feeling for the capabilities of each approach very rapidly. If you're in a production environment though, it's probably not worth it to spend time searching for the perfect solution. A mediocre solution is good enough more often than not. That was all we had to say about property drawers. If you have a specific kind of property drawer that you want to make, but you struggle with it, you can come by a Discord and ask for help. If it's a particularly interesting case, we may even want to make a short video out of it. But for now, the plan is to leave this topic behind and go explore other areas of editor scripting. As you hopefully know, we're always open to suggestions. All that remains now is to wish you a marvelous day.